Hello all. So we have finished our all concepts in control system. Each chapter we have finished from starting from basics of control system to our state space analysis. So I told you before that you have to learn each chapter such a way that it will fetch 2 marks each from each chapter. Correct. So its control system is very important. So we will discuss some problems which is asked in the recent GATE. This is 2021 GATE EEE. For the closed loop system shown the transfer function E of s by R of s. So everyone with the excitement they will write G by 1 plus GH, that is our first option. But they are asking E of s by R of s. So E of s by R of s is nothing but see, you can use your signal flow graph. R of s to E of s, how many paths are there? Single path, and we have only one loop, that is loop transfer function is or loop gain is GH, delta value is 1 plus GH. So instead of G by 1 plus GH, E of s by R of s is 1 divided by 1 plus GH. So that is option C. E of s by R of s. See, we have done a lot of questions harder than this, and they have simply asked this one, E of s by R of s, that is simply 1 divided by 1 plus GH. Always remember that you will do this problem. Similarly, the remaining previous GATE, the 2021 GATE, I think 87,000 people wrote, 87,000. So you will write, and the remaining at least some 75,000 people will get this same answer, 1 by 1 plus GH. Remaining they will write G by 1 plus GH, because the first time they are going, right. So do not make a mistake. What is the requirement? E of s by R of s. So you got 1 divided by 1 plus GH. Right. Move on to the next. It's 2 mark GATE question. The Bode magnitude plot, I think you can see it. The Bode magnitude plot for the transfer function V of s by Vi of s circuit is as shown. This is 2021 GATE. They are asking what is the value of R. So they are asking this value. So first of all, we know that if a figure RLC, series RLC is given, first we have to take down our V of s by V out of s divided by Vi of s we have to take. So we have got a transfer function M, and that is plotted against our frequency. So you have to crack like this. First you see this question, what you have to think? So I have got a transfer function, that is V out of s divided by Vi of s, and if you are looking into your Bode plot, you have got 26 dB, and always remember this is dB scale, magnitude in dB. It's very important, because sometimes they will give different values to fool you. Instead of giving in dB, sometimes they will give in real value. So always remember, and they will put logarithmic value here in the x-axis. We have seen question like that. And what is the information we are getting from here? At omega equal to 2000 radian per second or 2k radian per second, your dB is 26. So, that information is very important. Your magnitude is 26 dB at omega equal to 2000. So, just in the transfer function, if you substitute omega equal to 2000 and also the magnitude equal to 26 dB, you will get the answer. This is a direct question. If you see figures like this with lines, don't worry, it is a basic question only. You simply look into this. At 2000 radian per second, you have got 26 dB, correct. So, what is our for series RLC circuit? This value we do not know, this is Vi of s and this is V out of s. So, this is 250 microfarad and this is L, this is 1 millihenry. So, first of all, what is this is our series RLC circuit. What is M? M is V out of s divided by Vi of s, that is equal to 1 by Cs divided by R plus SL plus 1 by Cs. So, it is 1 by SCR plus S square LC plus 1. We already know that, and this is my M of S. Now, what is my M of j omega? M of j omega, that is equal to 1 by j omega CR minus omega square LC plus 1, if you put S equal to j omega. That is our frequency response, right. Now, what is the magnitude? The magnitude is given as 1 divided by square root of 1 minus omega square LC the whole square. This is A plus IB form. So, plus omega CR the whole square. Right. Now, this is our magnitude, and you substitute your magnitude and you equate your magnitude equal to 26 dB at what frequency? 2000 radian per second. And the next mistake you are going to do is you will write 26. No, that is 26 dB. If you have 26 dB, then you have to take 20 logarithm of this magnitude, correct. In dB means this is simply the magnitude. Then you tell me what is the real magnitude. 26 dB means you have to have some 20 log. Here is the mistake you are going to do. You simply equate 26 to this magnitude. This magnitude is simply the real magnitude, it is not logarithmic value. So, we have seen question like that. So, 20 log your magnitude is your 26 dB. So, what should be your M of j omega, the magnitude? Either you can use your virtual calculator, or we know that this is 20 plus 6 dB. So, I need a 20 log 10 and a 20 log 2. So, this is 20 log 10 into 2 I can write. So, 20 log 10 plus 20 log 2 is 20 dB plus 6 dB. So, that is your 26 dB. You got the answer? That is equal to 26 dB. Now, you tell me what is the real magnitude? That is 20. 26 dB or equal to 20 or equal to simply 20. So, you have to equate to this 20, not 26 dB. And if you are equating 26 dB, then you have to take 20 log. That is the main mistake you are going to do, and you will never get the answer. And see, this is numerical type question, right, up to is dash ohm round off to 2 decimal places. Even if you make some mistake, you will not get negative answer, but why do you waste your 2 marks? Now, I have my 1 by square root of 1 minus omega square, that is 2000. So, you have 4 into 10 raised to 6 into L is 1 millihenry into 10 raised to minus 3 into C is 250 microfarad, I guess, yes, into 250 microfarad. So, into 10 raised to minus 6 the whole square, plus you have got your omega CR whole square. So, what is omega? 2 into 10 raised to 3 into C, that is 250 into 10 raised to minus 6 into R square, that is equal to simply equal to 20. Finished, your job is over. So, 10 raised to 6, 10 raised to minus 6 cancelled, then 250 in so you have got 4 into 25, that is 100 into 250 10 is, that is 1000. So, this one, yeah, this is 4 into 25, 100, 1000 into 10 raised to minus 3, this whole term would become 1, or use your virtual calculator. So, 1 minus 1, it is 0. So, you have only this term. Now, again it is going to be very easy. That is why nowadays the GATE question, the calculation is very less, but the logic is more. Where you are going to do the mistake? Here, and you are not able to interpret this figure. There is nothing new. At omega equal to this, I have my magnitude, and how you can get the magnitude? From the transfer function, that is all. And here what I will write, this is square root of this value, the whole square, is nothing but, so we have only left with 2 into 10 raised to 3 into 250 into 10 raised to minus 6 R square, that is equal to 20, right. So, this square and this square root will be vanished, and you can find out the value of R. I do not know what is the value of R, they will give a range and you will get the answer. It is direct, these calculations are direct. The only one mistake you are going to make, do not substitute 26 dB, or otherwise you have to take logarithm, 20 log of this magnitude equal to 26, that is correct. Then it would be going to be somewhat difficult for you, right? Why are you going to take this? This 20. Okay. So, we will move on to the next question. It is again asked in 2021. So, this is this year 21 question, and it is okay. Consider a closed loop system as shown. This is a closed loop system. GP of s is given. I told you, no, there is no rule to say this is GP of s, this is GC of s. See, they can name anything. So, this can be A, this can be B, anyway. So, GP of s is given as that is the planned transfer function, and GC of s equal to 1 is the compensator. See, it is simply a compensator, and we can say that it is a proportional controller, right, KP. For a unit step input, yeah, this is step U of s, the output response has damped oscillations, okay, the damped natural frequency. So, to get your undamped natural frequency, damped natural frequency, damping ratio, we require our characteristic equation, and you compare. We have done so many problems like this. Again, this is 2 mark. So, to find out our damped oscillation time period, we need omega n and we need our damping ratio. and if you have omega d is nothing but omega n into square root of 1 minus zeta square. So, we will find out the closed loop transfer function, and we will find out, or simply we can directly write our characteristic equation 1 plus g of s into h of s, that is equal to 0, and then we will find out the answer. Okay. So, here we are going to find out our 1 plus g of s h of s equal to 0, and now here what is your total g of s? Gc of s into Gp of s. Overall g of s is the multiplication of Gc of s into Gp of s, but in the GATE exam do not do this, because already you know, directly you can write 1 plus 14.4 like that. So, 1 plus 14.4 divided by, it is s into 1 plus 0.1 s equal to 0. 1 plus g of s h of s equal to 0. So, it is 0.1 s square plus s plus 14.4 equal to 0. So, this is not your standard equation, because I told you that the standard equation is 2 s square plus 2 zeta omega n s plus omega n square. And do you remember, I told you that you have to remember this, s square plus 2 is the standard second order characteristic equation. So, while we solve so many problems, 50 types problems we have seen, 50, more than 50, correct. So, we will be continuously saying s square plus 2 zeta omega n s plus omega n square, like that. So, finally, this is not standard form, divide each term with 0.1. So, we have s square plus 1 by 0.1 is 10. So, 10s plus 144 equal to 0. So, now comparing with the standard equation, you have omega n square equal to 144 and omega n equal to 12, and 2 zeta omega n equal to 10. So, you have to find out the damping ratio, then you have to find out the undamped natural frequency. So, omega n is 12, now zeta is, so you have 10 divided by 2 into 12. So, you have got, it is 5 by 12. And what is your, now finally what is the damped frequency of oscillation? Omega n into square root of 1 minus zeta square. So, in time domain analysis, the first we are going to learn, we learned, that is our the roots of the second order system, the roots of the, first of all characteristic equation, and then roots of characteristic equation, what is alpha, damping factor, what is the time constant, what is omega n, zeta, then omega d, everything we are learning. So, one of that element is omega d, omega into square root of 1 minus zeta square, and resonant frequency, that is in frequency domain analysis, that is omega r equal to omega into square root of 1 minus 2 zeta square, right, and do not confuse everything. So, omega d is omega n into square root of 1 minus zeta square, omega n is given as your 12. So, 12 into square root of 1 minus 25, zeta square is 25 divided by 144. So, you have got 12 divided by 12 into 144 minus 25. So, how much you will get? And you will get this answer, 1 square root of 144 minus 25. So, that is I think 199, right, 119, and square root of that you will get the answer, that is omega d, and up to 2 decimal places, round off to 2 decimal places means, for example, if it is some 10.1234 something like that, you can write it as 10.12 up to 2 decimal places. this is more than enough, and they will give a range. So your answer should be in between that range. So that's why you can't write like don't add 10.12345 you can round off to 2 decimal place, and they will give a range from, they will say some 10 to 10.5, they will give that range, and your answer should be lying in between that range. It's easy question, right? Moving on to the next question. You have open loop transfer function of a DC motor 10 by this is your omega s divided by VA of s. Okay. You know omega is your speed of DC motor and VA is the armature voltage. Here I don't need that. When connected in feedback as shown below, the approximate value of Ka that will reduce the time constant of the closed loop system by 100 times as compared to that of the open loop system. So what is the time? First of all, we have to find out what is the time constant of open loop system, then we will go and find the time constant of closed loop system. So they are asking, they are connected in a feedback as shown below, the approximate value of Ka that will reduce the time constant of the closed loop system, they are reducing the time constant by 100 times as compared to that of the open loop system. Now what is our open loop system or open loop transfer function? Again, this is gate, the reason gate, and the total open loop transfer function what is your OLTF? OLTF is 10 Ka divided by 1 plus 10s. You remember the standard transfer function 1 plus St. So now here what is the time constant of open loop system? I could say T1, 1 plus St, that is T1 equal to 10 seconds. Now we are making this as closed loop system. Now what is CLTF? CLTF can be written as so 10 K divided by 1 plus 10s divided by 1 plus 10 Ka divided by 1 plus 10s. So this is 10 Ka divided by 1 plus 10s plus 10 Ka. 1 plus 10s plus 10 Ka. So I need 10 Ka divided by 10s plus 1 plus 10 Ka. Now we have to take the time constant of this system. So this should be in terms of 1 plus St2. So how can I write this? Take 1 plus 10 Ka out. So that is equal to 10 Ka divided by, I am taking 1 plus 10 Ka out, into 1 plus 10s divided by 1 plus 10 Ka. So now this is some constant, this is in form of 1 plus St. Now what is T2? T2 is equal to 10 divided by 1 plus 10 Ka. So T1 was 10 and T2 when I connected this system as, or when I am giving a feedback, the T2 is 10 by 1 plus 10 Ka. Now look into the statement. They are telling that will reduce the time constant. So we are finding the value of K that will reduce the time constant of the closed loop system by 100, reduce 100 times. So, how can I write 10 into 100 or 10 by 100? So, they are telling T2 will be equal to T1 reduced by 100 times, which means T1 by 100. So, what is T1? T1 equal to 10. So, T1 equal to 10 and 10 by 100 is 1 by 10. Now, substitute this value, T2 equal to 10 divided by 1 plus 10 Ka, that is equal to 1 by 10. Now, you can substitute, right, 1 plus 10 Ka equal to 100 and 10 Ka equal to, it is 99 and Ka would be equal to 99 by 10, that is 9.9. So, suppose if I have made some mistake in the calculation, just do not consider it, and this is the way you have to do it. First you have to crack each statement, okay, and you try it yourself again and try whether you are getting the same answer. GATE question. A closed loop system has the characteristic equation given by s square plus k square plus k plus 2 into s plus 3 equal to 0. For this system to be stable, which one of the following conditions should be satisfied? So, my characteristic equation is given as s cube plus 10 k s square plus k plus 2 into s plus 3 equal to 0. So, you have to check the system to be stable. What they are asking, the conditional stability. So, which way you have to go? That is, the best way is RH criteria, and I am going to draw my root array s cube, that is 1. Next element should be k plus 2, the coefficient of, so this should be k plus 2, and next is s square, that is k, and you have k plus 2 3, right. Now, what is s raised to 1? K into k plus 2 minus 3 by k, and here s raised to 1, s raised to 0, you can directly write your 3. So, for stability, each element should be, the first column element should be positive. So, this is positive, this is positive, this is positive, and this is also should be positive. So, k should be greater than 0. So, everywhere k is greater than 0, and k into k plus 2, that is k square plus 2k minus 3 should also be greater than 0. So, now solve this. You have minus b, k equal to minus b plus or minus square root of b square minus 4ac, and by using that, then you have to consider this condition and you have to consider this condition also, and we have solved so many problems related to it and find out the answer. That one I am leaving to you. So, find out the roots, and you have some factors k plus a into k plus b something that should be greater than 0, and you will get the answer. This is called as conditional stability. So, in the next session we will see with more problems which is asked in recent GATE. So, I will wind up this session and we will meet in the next session. Thank you.